Hello and welcome to a calculus tutorial by Physics Man Education. I'm Physics Man, and lately we've been dealing an awful lot with quadratic functions. Like that guy. And today what we're going to do is we're going to take this guy and we're going to put it into the so-called vertex point format. By doing this, we'll be able to extract certain information about the parabola described by the function. We'll be able to tell exactly where its vertex is specifically. So, here's how we're going to do that. First thing that we need to do is complete the square here. When we did this previously, we found that there was an issue with this a coefficient being not 1. So what we did was we just divided the entire equation by a. Today we're going to solve it in a slightly different way. Again, we're going to be following a strategy to get rid of this a coefficient being not 1, but we're going to do it in a different way just to expand our minds a little bit. Here's what we're going to do. We're going to say, imagine that u squared is equal to a times x squared. Well, what does that mean? Well, that means that u is equal to the square root of a times x, which of course also means that x is equal to u over the square root of a. Great, so let's rewrite our function. We could take y is now going to be a function of u will equal to this term, ax squared is equal to u squared, because that's how we imagined it should look. But now, where we have this x here, we have to also substitute u over root a. So I'm going to write it like this. Because b over root a is now the coefficient, and u is the variable. And of course here where we have c, well c is just a constant, that doesn't change. Terrific. Now we can complete the square from here. So we'll write y expressed as a function of u will equal to u squared plus b over root a times u plus b over 2 root a squared minus b over 2 root a squared plus c. So you remember when we did a tutorial on completing the square, that what we had to do is we had to take this coefficient, divide it by 2, and square it. And what we get as a result of doing all that, we have to both add and subtract. The reason why we have to add it and subtract it is because if we just added it, that would actually change our function. We wouldn't have the same function anymore. But by subtracting it here, we cancel it with itself. What that means, though, is that we can factor that into a perfect square, and this becomes a new constant entirely on its own. It's a constant because b2 and root a are all constants. And of course, c is a constant always. So, we'll do exactly that. We're going to go y expressed as a function of u, it's going to equal to u plus b over 2 root a, and that whole thing needs to be squared. When you take that square, you should get back this original form, and you can go ahead and verify that on your own. We have to keep this constant. I'm going to write it like this. B over 2 root a. Actually, no, I'm not going to write it like that, because that needs to be negative. I'm going to write the c first and then subtract. And that whole thing needs to be squared. The last thing that we need to do is we need to take our substitutions here for u is equal to that, and we'll be pretty much done. So I'm going to write y as a function of x now is going to equal, and I'm going to use some different colors here. I use blue for this squared part, so I'm going to have root a times x plus b over 2 root a, and that's all squared. And then I'm going to have to add to that the constant part. And the constant part I'll put in green. So I'm going to have c minus, I guess this will be b squared over 4a. When we bring the exponents out of the brackets there. Now, I promised you that by putting this function into this format, first of all, it's the same function as we have there. If you were to draw this curve, it would be exactly the same shape as that curve. And I promised you that we'd be able to find the vertex based on this format. Here's how we're going to have to do that. First of all, we have to solve for this is equal to 0. So, this equals 0 gives us x coordinate. So what we have to solve is root a times x plus b over 2 root a equals 0. Quite clear, we can take this to the other side. So root a times x is equal to negative b over 2 root a. Now, we're going to divide both sides by root a. So we're going to finally wind up with x is equal to negative b over 2a. And that will always be the x-coordinate of the vertex of our parabola. Now how do we find the y-coordinate? Well, the condition we had in order to find the x-coordinate was that this chunk has to be 0. Which means that y at that point will be equal to just the green part. So, y will equal just what's left in the green part, c minus b squared over 4a, will absolutely always give us the y-coordinate of the vertex. And this actually tells us an awful lot about the function. First of all, we can notice that if a is a positive number, then our parabola will be positive going to infinity at both x is negative infinity and x is infinity. And if a is negative, the opposite is true. So, if a is positive, we have a parabola that opens upwards like that. And if a is negative, we have a parabola that opens downwards like that. And based on this, we can find the point of our vertex of our parabola. And based on some strategies that we went over in previous tutorials about finding the roots, we could find the x-intercepts of our parabolas. So really we're equipped now to extract an awful lot of information about the parabola using very simple techniques. And there you have it. That concludes our tutorial. I hope you found it useful. Once again, this has been produced by Physics Man Education. I'm Physics Man. I'll see you in the future.